All right, I'd like to thank you all for joining us today at the API virtual event. It's a pleasure to introduce our speaker for right now, David Von Thenen. He's a principal developer advocate for Symbol.ai, his company. David, it's a pleasure having you. Take it away, sir.
Cool, awesome, thank you. So thanks for everyone for attending my session here. We're going to be talking about enabling untapped use cases in ML and AI, specifically edge, memory constrained, server side, and some others. So my name is David Von Thenen. I am a conversation engineer at Symbol.ai. What that means is I deconstruct a conversation and make it available for other people to consume easily through APIs and SDKs. In my previous lives, I've worked in the Kubernetes and CNCF ecosystems, some of those landscapes. Kind of prior to that, working on virtual machines, specifically in the vSphere environment. And kind of like all my day-to-day activities always revolve around with doing stuff in the cloud, whether it's Amazon or Google. And I have a big background in storage. So if anyone wants to chat about those things afterwards, it's awesome. For the agenda today. So we're going to first talk about like why we all don't know how to build X, Y, and Z, why we don't know how to build everything. Then we're going to talk about abstractions and ease of uses through SDKs. And then we're also going to hit on the next section, which is that SDKs are just more than code. It's really about enablement. And then I actually have a cool demo for everyone here. And then we'll open it up in the end for Q&A. So why don't we know how to build everything? So we inherently want to know how to build it all. Humans are just naturally curious creatures. When we see a problem, we always want to know and understand like why, like what are the details, like what things led to this particular problem. And it's kind of, just like I said, inherent because we all want to fix problems. So if you've ever seen the movie The Matrix, you got Keanu Reeves here, who is Neo. Neo's the main character in the movie. And one of the big arcs in the movie is that we're all digitally connected, and if you wanted to learn a new function or new capability in the Matrix, you could just download it directly into your head, right? You get plugged into this machine, you get some new program that gets downloaded into your brain. And if I go back to the previous slide, right, there's a famous quote in the movie where Neo's learning to fight Morpheus, and Neo, after he gets Kung Fu downloaded into his brain, he yells out, "I know Kung Fu," right? So we're kind of all striving to be and learn more. And this is an extreme example where we're looking to learn more quickly, almost instantaneously. So why we don't know how to build everything. So imagine if you had to build your cell phone in order to use it. If you had to learn how to build every aspect of your phone in order to use it, I'm guessing probably no one would know how, or no one would be able to use their phone, right? We all kind of know the basic high-level concepts of what it is about a smartphone that makes it a smartphone, right? We know that you can receive cell signals and you can talk, and there's texting functionality. And if you want to connect to the internet, there's a 4G or 5G antenna in your phone. But inherently, all of those components, if we look at this schematic, we don't know how to build all of those individual things. And forget about the hardware. Even the software aspect of a phone is inherently very difficult to build, right? You have iOS for your iPhone, and you have Android for Android phones, right? And so if we had to know how to build a phone in order to use it, we probably no one would be walking around with phones. So how about if we take a step back and make the problem slightly easier, right? What happens if we had to know how to build every part of a house in order to live in a house? So here's a slightly easier schematic or diagram, right? We know a house has 4 walls, many walls, but a room has 4 walls. If we want to see outside of our house, we need to have a window. If we want to enter our house, we need to have a door. If we want to plug the cell phone that we can't have into the wall, we need to have electricity. And then there's also plumbing for the kitchens and the bathroom. And so we all inherently know the components in order to build a house, but there's probably a few people who have actually built their house on their own, and that's amazing. But I think most people, in this room here, this virtual room, probably don't know how to build a house from the ground up, every aspect of that house. So, and if we had to build a house in order to live in it, I'm sure we would be living in much simpler structures than we do today, right? So let's even take a step back from that. We kind of all understand the basic materials it is to build a house, right? There's bricks, cement, concrete, glass, wood, right? But even these simpler building materials, I'm guessing, myself included, don't know how to build on our own, right? I'm sure there are people out there who can blow glass and make sheets of glass for windows, but I myself don't know how to do that. I'm sure there are people out there that know how to take a huge log and mill it down to wood so that a useful 2x4 to build the support structure for a house. And even cement and concrete, I'm sure there are many, many more people that know how to mix concrete and know how to lay a foundation. But if you even take the simple building blocks of everything and you needed to know how to make those things in order to build the larger thing, the house, I think we would still, like I said, be living in a much simpler structure than we do today. So let's take it even one step back further. Something that's very beyond easy, something that's very fundamental to every civilization, every continent, just making fire. I think if we all had to know how to make fire from scratch without using other tools that came before us, I think there would be a lot of people that would be living without fire, at least for a little bit, right? I mean, it's not entirely complex. We know kind of the basics. I myself, I've actually taken a survival training course, and I know that you need to have fuel, wood, and if you need to, in order to generate heat or fire, in my survival training class, I had a stick and I had another stick combined with a string, so you can make a bow so that you can whittle the stick faster and faster in order to generate heat. And then you need to have a little bit of timber at just the right area that's dry and blow on it in order to get the spark going to create smoke and then hopefully a fire. The reason why we don't all know how to make fire is the same reason why we don't know how to build a cell phone or don't know how to all build a house from scratch. It's because there are other tools that are out there that make it easier for us to consume and get to that end result without having to know the underlying details of how to make a fire. So I've been kind of dancing around this subject about SDKs, and they're really abstractions and ease of use constructs, right? In that survival training course and how to make a fire, my survival training instructor basically said, hey, it's great that you know how to make fire. If you ever come into a situation where you find yourself where you can't get to tools, it's great. But at the end of the day, my survival training person said, hey, you have a lighter. There's other tools and implements that are out there, like flints and stuff like that, that allow you to create fire without having to know the very basic details about how to actually start a fire, right? And so what this kind of boils down to and how it relates to APIs and SDKs and software in general, right? So APIs are the basic kind of very fundamental building blocks of how we interact with software, how we interact with software systems. They are kind of essentially how I talk to or how I build a fire, if I'm kind of making that analogy. And so if we wanted to create an EC2 instance on AWS, right, there are APIs available or contracts in which there are certain calls, whether they're REST calls, gRPC calls. There are calls that we can make in software to contact the other side of this cloud and say provision an EC2 instance with this amount of memory, this many CPUs, and this kinds of storage for this kinds of like performance profiles. Now imagine if we had to actually provision all aspects of Amazon's software that's out there, and we had to do that all directly using APIs, not using SDKs. So what I'm going to say to that is that contracts aren't fun, and kind of by extension, SDK or APIs aren't necessarily fun. If we had to interact with these systems using raw APIs every single time, and anytime a new developer came on board, we had to figure out how to make a REST client, and we had to figure out how to do a post with this kind of JSON input so that we can actually provision an API. It would take a lot of effort to get to where we wanted to go at the end of the day, which is just provision an EC2 instance. And so you see Keanu Reeves here yawning, and it really isn't fun. And kind of why software development kits are awesome is because it makes it easier to use. So maybe it makes software easier to use. There's a reason why we don't interact with those APIs, just like there's a reason why we don't know how to build Fire. There are other tools in the form of SDKs, like Amazon has, they have their API set, they have their SDK set, and then they also have like the Amazon CLI to make it easier to call into their cloud. And so there are much easier ways to get to that final destination or that goal or that target than directly using those APIs. So when you hear software development kits, those are mostly inherently good things, right? Things that people really enjoy using because it severely decreases the time to ramp up to get to where they're going when they're building their own product or their own project. So I created a Go SDK for Symbol, and it's open source, so you can actually see it on GitHub. And like I said, it is Go based. And I'm bringing this up because, and actually before I dive into it, I'm bringing it up because it's a part of my demo. But before I get to that, I kind of want to tell everyone here about like what Symbol.ai is. So we're a conversation platform that allows developers in code using APIs and SDKs to break up conversation. Like imagine if you're in a Zoom video and you want to be able to break down what was said, so like basic transcription, or you wanted to access certain topics that were talked about in this Zoom video. You want to be able to get a summary of like what happened in this hour-long Zoom video. Instead of watching this hour-long Zoom video, we condense it down to like a one paragraph statement that says this is the main highlights of this conversation that happened in Zoom. So Symbol allows you to do all that programmatically. It exists and able to do this over video, audio, telephone, text, like I said, through APIs or SDKs. And we're a platform or software as a service. So instead of like having to do your own machine learning and training and all that stuff, we work on unstructured language, so you can basically make an API call on any type of conversation and kind of get these conversational insights about them. So why did I bring all this up? So when I first started at Symbol, I was like, hey, this is really cool. I want to build a Go SDK because I have these ideas about kind of where I wanted to go with this. But why Go? So I took a look at the SDK sets that are not only available at Symbol, but also at our competitors. And they kind of seemed very similar to each other, whether they're at Symbol or our competitors. And there's actually good reason why that is, right? There's actually a definitive one-to-one, this is a good thing because of, and I'm actually going to go through them right now. So one of the big languages out there when you're trying to make an SDK to deconstruct a conversation is JavaScript. And if I'm talking about Zoom videos or CPaaS platforms like Twilio or Vonage, it makes sense there's a JavaScript library, because if you're going to open a web browser and you want to be able to interact with conversation and take a look at what's going on the microphone stream and do transcription and all that other fun stuff, a JavaScript library for a web browser makes a whole lot of sense. And it also makes a lot of sense that there's a lot of platforms that target Swift and Java. And the reason why is because there are more mobile devices out there than anything else on the planet, right? So there's Swift for iOS, and then there's Java for Android phones. And for anyone that's worked in the machine learning or artificial intelligence space, a lot of those projects are born out of Python. So it also makes a lot of sense that when you're talking about machine learning and artificial intelligence, just like Symbol has, we use ML and AI on the back end to deconstruct language. And so it makes sense that because we have a very heavy AI and ML background, then it makes sense that those things, because a lot of that infrastructure is written in Python, not just at Symbol, but in general. It makes sense that when people are familiar with Python and the language that's being used in that space, that you just naturally have an SDK that covers that language, right? So, but this goes again back to like, why Go? Why did I say, hey, like, I get there's a JavaScript library, I get there's a Swift library, I get there's a Python library. Why did I create a Go SDK? And what it really comes down to is that SDKs are more than just code, right? It's actually about enablement. There are, when I set out to create this Go SDK, right? Because there are SDKs and languages that were already very familiar with the community, it makes sense that they exist, right? Because the community is more familiar with them. But creating a Go SDK allows people in other communities who might not be familiar with like web languages, like web front-end languages, who are interested in using our platform or conversation platforms in general, that might not be able to access or easily consume them because they aren't languages they're familiar with. And so that's kind of like the big reason why I decided to create this Go SDK. And when I created this Go SDK, if anyone who's familiar with Go has very cool characteristics why that make Go like really awesome in the spaces that they play in. And one of the things, just by creating a Go SDK for our platform, one of the things that it enabled was to have code live on memory constrained devices. So this is a picture of a Raspberry Pi. Because Go gets compiled down to machine code, whether it's x86 or ARM, you can literally land a small amount of Go code in the form of a binary and have it execute on an ARM system. If you had memory constraints and you were looking at doing it like, hey, you can do the same thing in JavaScript, no problem, or you can do the same thing in Java. And actually, in memory constrained environments, it actually turns out to be a difficult thing because you have a JVM or you need to have a JavaScript engine. And so another thing that it also enabled is edge devices, right? Devices that are so small that they have very little memory and very little CPU to crunch numbers. And so Go also enables these users to access our platform. And it also turns out Go is very useful for doing things at massive amounts of scale, right? Doing stuff on server-side processing instead of client-side. If you notice, most of the languages in the SDKs that I had talked about, other than Python, like Swift, Java is also kind of a back-endish, but it's mostly used for Android. And then JavaScript itself, they tend to be more front-end leaning, client-side leaning languages, especially in this space. And so having a Go SDK definitely lends you to build things out and scale out, like in a Kubernetes cluster, for example. And if we're talking about things at scale, now we're talking about conversations at scale. Instead of looking at conversations that live in isolation, right? Instead of all of the conversations being processed in the Zoom video just in that, the container of the 5 people that were in this video and then processing the language, it gives us the ability then in Go, right, because we're talking about at massive scale, to scale out and to take conversations and aggregate that information among many conversations and maybe put something that was said in one conversation and something that was said in another Zoom video and put the dots close enough together where we can be like, wow, these two things are connected because of this. So yeah, that's kind of like why I built this SDK. It's basically it's about enablement, allowing other people to connect. So I'm going to give you a little demo. The reason why I brought up Go and everything was because like the first thing that I thought of, and I thought it was really cool, is, hey, if I had Go, a Go SDK for our platform, it would be cool just to create a virtual assistant. So I actually did. I created an open virtual assistant. You can see the GitHub page there. I just cut the release like just before this talk. It's basically a framework that allows you to build like an Alexa or a Google Home. And you can drop it on your computer, which is what I'm going to demo today, or on a Raspberry Pi or an edge device or whatever. So let me go ahead and demo that really quick. I'm going to switch my screen share to a command line prompt. Hopefully everyone can see that. I believe they can. So if I just run my virtual assistant here, right, my open virtual assistant, hopefully it starts up. How are you today?
I am good. Thanks for asking.
What time is it?
The time is currently 1:51 p.m. Pacific.
What is your name?
My name is Symbol Susie.
What is your quest?
To seek the Holy Grail.
What is the airspeed velocity of an unladen swallow?
What do you mean? An African or European swallow?
So I know this is kind of like just a fun little demo. It's kind of like the first thing I thought of when I was like, hey, I'm going to build something very cool with using our platform, the Symbol platform. In order for me to do that and drop this on a Raspberry Pi, I needed to have something that was in Go because of the things that I had talked about, like memory constrained devices, edge use cases and stuff like that. So yeah, I hope, tying all this together, APIs are great. They're the backbone of how we interact with software. But, for me as a developer, at the end of the day, I want an easy to use SDK. If you want to learn more about like the stuff that I've talked about here, you can definitely take a look at all the resources that we have available. And if you're interested in just having a chat afterwards, you can join us on the community. So symbol.ai for Twitter and Slack. And then there's also our GitHub page. And I will take questions if there are any. Anyone got any questions? So the question was what was the GitHub again? So like which part, the Open Assistant or the SDK? So the Open Assistant was, or is, right there. I'll actually tweet about it. I actually did cut the release, but I haven't tweeted about it, but it is there. So there's a 0.10 on GitHub right now. There's what the demo that you saw is the example that I give in the repo. There's definitely going to be, I need to reorganize a little bit like the code because, obviously I was trying to cut it close for this presentation here. But yeah, I'll do a little reorganization, but like the code for this example is in there. And then I'll just, since I'm here, for the SDK that was used, you can find that code here. And like I said, it's on GitHub and it's all open source. And I think I might be coming very close to my time. If there are any other questions? If not, like I said, I'm glad everyone is able to hang out and talk about APIs and SDKs. Like I said, if you're interested in talking more about that, visit us in Slack, and you can hit me up on Twitter, DM me, and it was very cool to talk to everyone today. Hope you have a great day.